in dogs, there's a hereditary type of deafness caused by a recessive gene. And recessive genes are depicted by small letters. Two dogs who carry the gene for deafness but have normal hearing are mated. And they were kind and gave that to you. So they're dominant for hearing, so the big D and the big D, but they both carry a recessive deaf gene. What are the possible genotypes and phenotypes of their offspring? So phenotypes are what you can see. These are the physical attributes. So white fur versus black fur, blue eyes versus brown eyes, hearing versus deaf. So phenotype is the physical aspect of the gene. The genotype is the double letter. So the next thing we're going to do is connect the letters. We take from the top, take from the side, take from the top, take from the side, take from the top, take from the side, take from the top, take from the side. So what we've got here are three different genotypes. We've got a double dominant or homozygous dominant. Homo means same. Homozygous dominant. And then we've got two heterozygous dominant. Hetero is different. So we've got a big D and a little d. That is heterozygous. And we've got one double recessive. This is also homozygous recessive because they are both small. So the first thing we're going to do on this table, we've got the double Ds, the double big Ds, the big D genotype. Then we've got two of the big D, small d genotype. So big D, small d. And then we've got one of the small d, small d. So those are our three genotypes based on the two parents. So our phenotype for the double dominant hearing, this dog can hear. These two dogs can hear because they also have the dominant. And this poor little guy is deaf. Then the chance, and again, this is simplified, but the chance of having double dominant or homozygous dominant is 25%. Each one of these boxes is 25%. The 4 boxes equal 100. And that means this has to equal 100. So we've got big D, 25% chance. The big D, little d, this one and this one, 25, 50, 50% chance. And the small d, 25% chance. So on this next one, they kind of help in the way that they give you the table. So you know you're going to have 2 genotypes. And that's just the combination of dominant and recessive genes. So here, you know you'll have 2, and you just start this by combining top and side. And then the phenotype will be what you can see. And in this case, it's either going to be short-haired or long-haired. And then what are the chances based on 25% per square? If there is one square with one and three with another, that's 25 versus 75. If it's 2 and 2, that's 50-50. Or if it's all the same, it's 0 and 100. And those are really the only three combinations you could have for percent happening or percent chance. All right, let me know if that helped, and just send me any questions. Talk to you soon. Bye.